Welcome, everybody. We're going to be working on the Module 3 Lab 1 here. We just did a little bit of lecture on while loops, and we do have it linked up. So we're linked up to W3 Schools and their while loop page for Python if you want to read that content before you watch this video. We have a task to create 3 different while loops here. One that just is going to basically put some numbers up on the screen, a real basic while loop. One that has a little bit of user interaction involved, and then another one that's a little bit more complicated in that it has a menu structure and it allows the user to make their choice and ultimately also to exit the program. And that one will be the most interesting one, especially from the user interface standpoint. Over in Visual Studio Code, I preemptively in my file system created a folder for the work here, and I created a new file called Module 3 Lab 1. And then I just put in a little snippet of information. Here it says a while loop repeats something so long as its condition is true. So kind of like an if statement in a way. Now the way a while loop works is sort of like this. So I'm going to paste in these. This is in the form of comments. You guys do not have to type this in, students. But a while loop, first of all, starts the keyword while, right? Then we add a conditional expression, which is the true false thing that we're checking, just like we do an if statement. So there it shares a commonality with the if statement. What we learned also in the lecture part of this is while loops in Python also accept an else, which is unusual compared to other programming languages. I don't see a lot of people leveraging that, but it is available. Then there's the body of the while loop, which is what statements are executed as long as the condition is true. There is some other stuff that I'll throw in here, right? And so some of this is terminology. So mind you, right? So often when we do a while loop, and as we saw in the lecture piece, you do a while loop and you're working with a value that you're checking maybe against a different value. And often we either increment or decrement that value. We call that sometimes the index value or the counter, right? So these are all terminologies that we use. Other people will refer to that variable as the sentinel value or the loop control variable. It's all depending on like what language you're coming from or what background, but you hear all of that terminology referring to it. Every time a loop runs, right? Think about this term. Hey, what's another word for repeat? Reiterate, right? You guys have heard that one, like most people have heard that term. And then that's if you repeat over and over again. But if you just repeat once, it's called iterate or an iteration. So this is terminology we kind of throw around in programming often. So if you hear a geeky person like me say, hey, did you do an iteration of that loop? That's what I'm talking about. The loop ran at least once. Every time the loop runs, it's an iteration. And to do it actively is to iterate. Right? Often with the loop, we start with some sort of a loop control variable or sentinel value. And with while loops, there's a responsibility on the programmer to preset this before the loop is declared so that we can trigger the loop to run in the first place. So I'm setting up the letter I as a variable to hold the number 0 currently. Okay, so you might ask, why the letter I, why not the letter A? Well, this comes from mathematics, by the way. When you learn how to do calculus or trigonometry and you have like these complicated functions basically that iterate also. So like in mathematics, they have functions that loop. I is the value that we use as the index to run it. So this is, where some of that terminology comes from. So very common in programming to use the letter I to run a loop. So here's an example statement here. And this is very similar to what we saw in W3 schools. But while I is less than 5, notice the colon, kind of like an if statement. Notice also the indent. The indent indicates that this next line of code is inside the loop, by the way. So every time the loop runs, we're just going to print I to the screen. Right? Now I need to change the value of I, because if I don't, we potentially could get stuck in the loop I'm going to use the plus equals approach. I'm going to say I plus equals 1. But I just want you to be mindful that I plus equals 1 is the same as saying I plus 1, and then storing it back in I. Programmers, once they learn this trick, they usually go with this approach every time. So this is to increment. Why do we increment? All right, so here's kind of what I typed last year when I taught this. Without the increment, you get an infinite loop. It's generally not good, right? Yeah, usually not. Okay. Now, it still wants to stay inside the loop, and I'm going to backspace and go back to the margin here. Let's just run this part and make sure the first part of the program works, right? This is just to print these numbers. So Control S to save. Here comes the runtime on it. Okay. So it printed 0, 1, 2, 3, 4. It got up to 5. It checked it. It's not less than 5 anymore, so it didn't print 5, right? But it started with 0 because that's where I started. And of course, you can tweak this and adjust it. And we did that at W3 Schools. We played with these numbers. And we also played with doing a decrement, right? Switching the sign the other direction and counting down. Right? Those are all possible. The next prompt was to have the user do this. So let's go back here and just take a look really quickly. And that is create a while loop that runs until a user enters the word "and," quote unquote. Right, so this is, notice that we put the message on the screen letting the person know, right, that, hey, you can do this, by the way. All right, so I'm going to mimic that. Now, some of you might say, well, I should do a print statement first to tell them, but I'm going to show you a trick here because you can put an input statement right in the while loop condition. We did this with an if statement in that last assignment. So I'm just going to do a prompt right here in position, and I'm going to say type and. Okay, well, here comes a problem. I want to put that inside double quotes. Okay, I can't. Oh, yes, you can. There is a way. So we learned how to do, for example, a \n add a blank line, or a \t to add a tab stop to the output. You can also add a / in front of a double quote, so it ignores the double quote as the closing double quote for the statement, and then still add a double quote at the end and have the statement be valid. So this will actually print out the double quote. So it's an escape sequence that allows you to put a double quote on the screen. So type end to end.
Can't you also do single quotes and then the double quotes within? At least that's what I did. It seems to work. Okay.
This is my attempt to demonstrate the escape sequence, Alexis. But yeah, Alexis is right. I could just put either single quotes here, or I could have put single quotes on the outside. That would work just fine. Then I wouldn't need to put those there, right? And that's why you're allowed to use both, by the way. All right. So if that input, think of the logic of this, does not equal the word end, they can type anything else and the loop will run. But if they type end, we want it to stop, right? So it's only going to happen if they don't type end. Right, so the control is in the hand of the user. So every time the program runs, we're just going to put the word continued on the screen just to show that it's iterating. And if you want to be silly, it is iterating, right? I'll be a computer geek, right? Now, one approach, right, that we can do here. This is enough to make it work. And how do we know we're done? Well, you know what? Here's what I would do. I would put a statement at the end, just a print statement. Program complete. Maybe thank you, come again. Something like that. Just to let people know you're out of the loop, because otherwise it's just going to stop. Right, so I'm just doing that to see, right? So let's run this just the way it is. All right, so here it is up on the screen. We got the 4 numbers because they're there. We don't want to type end right away, but I am going to type don't end. Nonsense, 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 and okay, and the program's done. Another thing, if you want to experiment with the fact that the while loops in Python also have an else, you can throw it in here. So like one thing that you could do, and I'm going to say this, and I said this last year, I don't see a lot of programmers in Python using this, but it is there. And I think a lot of people just don't know it's there, right? And then you can have an else. So like if you don't match the condition at the top, instead of having this at the bottom, right? I'm still going to leave it there, by the way. You could have a statement here that just has something like, done, something like that. All right. So just to show you how that works, Control S to save. Here comes the runtime again. There's our numbers. We'll type whatever. So it's iterating. Then we'll type end, and it's done. And then the program's complete. It's just to demonstrate the else. If you guys are wondering. All right. Next thing that we are prompted.
What does the else get you in from a logical control standpoint that just putting that code outside the loop after the loop wouldn't get you?
Mike, you're identifying exactly the reason why most Python programmers don't use it. Right? Because it's kind of the same thing that we did with that return statement, right? Where we had the else and you could have returned 0, or you just return 0 because you're popping out if you're hitting a return statement anyhow. I don't, like I said, it's not commonly used, but it can. Do I functionally use it when I write stuff? Like never, And I will admit that part of the reason for that is I'm not used to doing it because, like you said, I could just put this statement after the loop and it would basically operate the same way. So what's the point? The only reason it would be useful, like maybe in this situation, is the person types end to begin with, and you just have a message that comes up as a result of quitting immediately, right? Or here, how about this? Instead of saying done, you could say quitter, something goofy like that, right? And I'm trying
Now,
to,
if it went back and re-evaluated the initial condition after the else, that would be cool. I could do lots of things with that.
Yeah, but it doesn't. Yeah, and functionally, I don't see a lot of a reason for it. So take it for what it's worth. All right, let's look at the last little prompt because that one's a little weirder. It says the current number is 1, right? So create a while loop that increments or decrements a number based on the user selection, right? So it'll indicate what your current number is, right? And it looks like it should start with 0. Then we put a menu up on the screen. Okay, select an option, right? So we'll find a way to display that on the screen. The user is going to type in their option, and then we'll check that. And in this case, they're adding 1. So then you get the message, your current number is 1. And then you repeat the process. So you're choosing if you're adding or subtracting, and you're choosing whether you're ending the program. So when is that loop going to stop? When the user decides it's going to stop. And there we go back to this whole discussion about while loops. While loops are particularly useful when doing user interfaces. That's where they're most useful in my opinion. Right. Let's go into coding this. This one's a little bit weirder to code because, all right, we have that current number thing. Before we even go into the loop, I'm going to create a variable here called current number, right? And I'm being very verbose with the naming. And because they started at the number 0, I'm setting this at the number 0. And then you might think, okay, what's the condition going to be here? I can't really base it on the current number because then I'd have to come up with a limit. Like, what if they want to run this we start at 0, but what if they want to run the program up to 1 million? Am I going to stop them? I don't know why they would ever get that high. I don't want to stop them. So what I can do, and this is really weird, because when we write a condition statement, we're looking for a true false value. One thing that we often do with user interfaces is we just set the while loop to true. Now think about this. It's just going to run forever. The way that we get out of it is by using if statements or some sort of selection process inside the code that allows us to break out. Okay, so follow my logic on this, if you would. All right, so the first thing that we're going to do is we're going to do some output to the screen. And yes, I'm copy pasting this for speed and efficiency. And so the first thing I'm going to put on the screen is the current number is, and the first time it's going to say 0, right? And then select an option. Notice the tab escape sequence here. So these are indented, right? And so we're either going to add one to the current number, subtract one from the current number, or end the program. So this is just going up on screen to prompt the user every time we go through the loop, right? Next thing that we're going to do is we're going to set up a variable, and let's call it user selection, right? And this is what we're going to grab input from the keyboard. And so we'll have a simple input statement, something to the effect of, and we'll do this as an F string, by the way. We'll do a tab stop, and we'll say selection. Spell it right, though. And they're entering numbers, right? We're asking them to enter 1, 2, or 3. So I'm going to convert this to an int. And as Mike discovered for us, when you convert to an int or a float, it automatically strips trailing and leading spaces. We don't have to put that command in. So that's very useful to know. And thank you for looking that up. So here's where we capture the input, 1, 2, or 3, hopefully, right? Convert it to a number, store it in user selection, and now we can do our logic checking. So now we just use a regular if statement. So for example, if the user selection is equivalent to 1, what is our action? We're adding 1 to the current number. So we're just going to say current number plus equals 1. All right. Then we do an else if. And now I feel compelled to do a little bit of like logic searching in your brain here. If the user selection equals 2, right? I think you guys already figured out what's going to happen here, right? Then with the current number, we minus equals 1. We subtract 1. Easy, right? Let me ponder this question for you. If I didn't have an else if and I just used an if, would that still work? Yeah, you guys are going, Yeah, it would totally work the same, by the way. But we do want it to check in sequence. So else if it's a 2. And then we also are going to have another else if, and I want you to consider this. Could I just do an else? Because otherwise it has to be 3. Because they could type 4, or they could type a letter, right? So I'm going to do else if again. So elif, the user selection is equivalent to 3. What happens in that situation? We want to end the program, so we can do a break, right? And I'll say this will pop us out of the loop. This is our exit point. This is how we get out. The user controls it. They type the number 3 and they're out of the loop. So the loop's not ending until the user decides. We do have an else to throw in here. What's the else? Well, the else is they type something other than 1, 2, or 3. So I'm going to give them a message to that effect, right? And what did I say last time? I said, you need to select 1, 2, or 3. This is as simple as that. Then that will end our loop. Now, what I'm going to do here is I'm going to put this so it's all on the screen at the same time. You can see all that code. And I apologize for a little pop-up there. I know some of you are trying to capture it and type it in just in case you missed anything. So we preset the current number. We trigger the loop to true, it's just going to run. We put up a little menu, grab their input selection, convert it to a number, check the number for the condition. We're either adding one, subtracting one, exiting, or if they type the wrong thing, not one of those numbers, we let them know about it and run the loop again. And maybe, I'm just throwing it out there, maybe we need to do a blank line in there too. And then down here, I'm going to put a blank line in front. I'm leaving the program complete. Thank you, come again thing, just for my own amusement. All right, let's go ahead and run this one so you can see how it operates. So Control S to save. I'm going to make the console a little bit bigger. All right, so we got our loop from before. We already saw how this loop works. I'm just going to type end, right? Quitter. There you go. Right. So my own loop is insulting me. The current number is 0. Select an option. Add 1 to the current number. Let's try that. Current number is 1. I'm going to add a few. Right. So you can see it incrementing. Now I'm going to subtract a few. I see it decrementing, right? So a little syntax there too. Increment, decrement. And those mean to increase by 1 or decrease by 1, by the way. And then we have well, let's type a 4 because that's not an option. Right? It says you need to select 1, 2, or 3. Then puts the thing back up on the screen. I'll type a 6. I'll type a H. Oop, that doesn't, it doesn't know how to handle that. All right, that broke it. Leave it to me to break the code. But let's go in there and just type a 3 to end the program. So that's our way out. But the user can get themselves out of this. I think that's kind of cool. All right. I'm going to go ahead and pause the video here, assuming it's still recording. All right, we are back from break and we're going to move on to lab number 2. And we're going to throw in, we're still working with while loops here, but we're going to throw in something brand new, and that is a random number generator. So I'm going to just very quickly look at the documentation here on W3 Schools. I'm going to close these previous tabs here just to save a little bit of memory. But whenever we want to run a random number generator in a Python program, that does not happen with the native library. So we do have to import the random number generator. And the statement is really simple like this. So it's just a random, import random. You throw that at the very top of your program, along with any other import statements, and you can utilize the tool. So this is, I think, maybe the second or third time we're using an import statement. But without that, the random number generator just won't work. In order to generate a random number, and I want you to take a look at this, the way the syntax works on this, we call the random library. From within the random library, and this is with dot notation, we're calling a function called randint. And guess what that does? It creates a random integer, and we set up a range. So between the numbers of 3 and 9, this will generate a random number somewhere in that range and put it up on the screen. And because it is inside of a print statement, I could also take this and feed it into a variable if I wish, or any other aspect of the program. In this case, we're just putting in the print statement. But to show you that it's truly random, you could paste that a few times and run it, and you should get, different numbers within a range, right? Some might repeat, but generally they're different, right? And then of course you can change the range. So you can go from 1 to 9 if you wish, or 3 to 1,000, whatever. It doesn't really matter what the range is, but it will do it, right? Just to show you, right? Very, very simple to use, and that's really kind of all the knowledge we basically need to do this program that we're doing. There are other things that you can look up here, but this is like the very basic use of random integer. All right, let's go back now and take a look at the lab. All right, so the requirement for this one is create a function called getRandomNumber. The function should have no parameters, so we're not sending anything to it. the function should get a bottom number and a top number from the user. So the user is going to pick the range, basically. The function should return a random integer to the user based on the bottom and top numbers. Okay, that's pretty straight ahead. Call the random number function to get a random number. So obviously we're going to write the function and then we're going to call it, and then use a while loop and user input to allow the user to guess the random number and then decide if they're too high or too low, and then you let them know. All right. So I don't know if you guys are feeling where this is going, but have you ever played that game when you were a kid? You know, pick a number from 1 to 10. I got one in my head, right? And too high, too low. Yeah, that's it, right? And you got 1 chance in 10 basically of getting it correct. But that's what we're basically building here, is a very simple version of that. So let's go ahead and get started on it. I'm going to go ahead and create a new file here in my folder, and I'm going to call this module 3 lab 2. You can call it a number guessing game if you want. That's fine too. All right, so let's get started here. And we know that we have to do the import. So I'm just going to grab that from my other code here. So I'm just doing an import random, bringing in that extra code so we can run it. Let's set up our function. We were told to prompt the user for a bottom number and a top number, and then we will, let's do that part of it first. Let's define it. We're going to call this get random number. Nothing's being thrown in. It's going to generate its own values and grab its own values from the user. We'll set up a variable called bottom. We will do a convert to integer, and then inside here we'll do an input statement, and then the prompt will be select a bottom number. And since the process is very similar for the top number, you may as well copy it, make an adjustment, we'll call it top. And we'll just switch the verbiage, but basically the same statement. Quick, easy copy paste, couple word tweaks, and we're done. And then we're going to return from the function. We are going to return a value. So I'm going to type return. And the return is going to be the result of the random number generator. So I'm going to say random.rand int. That's the one that we just learned about. And then inside the parentheses, the parameters will be the bottom number, comma, the top. In the example at W3 schools, they just hard-coded the numbers. This does return an integer, and I'm kind of hovering over the function so you see that, because that's what rand int does. It returns an integer. That's what the verbiage says there. All right, so that's our function. All right. All right, so think about how the guessing game would work. User starts the program, and you know what? When should the computer pick the random number? How about right away? The user doesn't even know it, like, right? Because if you play that game with like kids, it's like, I got a number in my head, guess a number between 1 and 10, right? So the computer's going to do it right off the bat. I'm going to just create a variable called random. I'm going to name it with camel casing this time, so capital N in the middle. And that's going to be equivalent to running the function, because that's going to return the random number. Okay, so one thing that you might say to yourself, well, I could just run the random number here, right? And just put in a value, but you don't have the user control over it then. So that gives us our user control. Now the user is going to guess their value. All right, so let's just call that user guess, right? We'll prompt and convert to an integer. So we will do an int. Inside there, we will do an input. And then the prompt will be something like guess a number. So first they're going to get prompted. Select the top number, or select the bottom number, select the top number. And now we're asking them to guess a number because the computer's already picked one. All right, here comes the while loop. All right, so now what happens if they guess the right number right off the bat?
The program ends.
Well, we're done, right? Yeah, I mean, because if they guess the right number right off the bat, so this is like where the while loop selection piece comes in kind of handy. And I'm just going to kind of put this in here because this is going to be the ending of the program, is the guess is correct, but we do need to test it. So we'll just say, while the user guess does not equal the random number, we're going to run the loop. If it does equal the random number, well, we just put it on the screen and we're done. We don't need the loop. Feel where I'm going with that? So sometimes with these loops, sometimes you have to use like reverse logic to trigger it correctly. All right, let's go into the loop and build it. So, all right, so they got past, this thing that, okay, they didn't pick the right number. So if the user guess is greater than the random number, the message should be too high, guess again, right? That should be the basic message. So we can just basically, I'm going to use my prefab version of this, but you could copy, this statement and tweak it. So that one up here, you could copy that one, but I already have it built. So I'm just going to say, we're going to prompt again, and we'll say, whatever you guessed is too high, guess again, turn it into an integer, drop it in, and then of course the loop would run again, do the comparison. If it's correct, it drops out. If it's not correct, it asks again. But there's also the scenario of else if the user guess is less than the random number, right? And then we would do the same type of prompt. Think about it, except the message is reversed and we just say too low. And it just keeps going. Notice there's no else to this. I can't assume there's an else, right? Because if they hit it, so think about the logic of this. If it's equal, we don't need an else. We don't need a third condition. That's handled out here. Okay, going back to Mike's original question is, why would you ever use an else in a while? I mean, could use it in that scenario, right? They don't get to exit out until they get it correct. Now, obviously, when a person runs this program, you don't want to use a really large range because we might be sitting here all day until you get the number right. But there's actually an algorithm for this, and this is one of these goofy things. I think I had to like write a math solution for this when I was like doing my master's degree. Depending on a range of numbers given, how many guesses should it take for a user to narrow it down? And there is an algorithm that if you follow the too high, too low thing, and I forget, like if it's between like 1 and 100, you should be able to do it in 7 tries or something goofy like that. I don't remember what the algorithm equals, but you can probably ask ChatGPT, I guess. Right. Somebody want to do that and report back. I would be very curious to the answer. All right, let's go ahead and run this. So that's the complete program. So here comes the runtime. Select the bottom number. Let's start with easy. Let's do a traditional 1 to 10, right? Okay, guess a number. Well, what do you guess? Well, you guess 5, right? Right. So then it's too high. How about in the middle of that? Well, I guess 3. 2? Okay, 1. All right, there you go. All right, try it again. Let's do 1, and let's do 100. So let's see if I can do it in 7 guesses. If my guess was right. Guess a number. All right. Right. Logic says you should guess 50. Then I'll go with 25. Then I'll go with 12. All right. We got it narrowed down. So how many guesses is that so far? 3. So in 3 guesses, I've narrowed it down to like a 13 number range, less than 13, right? 12 numbers. All right. So what should I guess? 17? 22? 20? 19? All right, that's how many guesses so far? 6. 7 guesses. I like that. So I guess that's somewhere stuck in the back of my brain. I don't know why I retain goofy knowledge like that. It's probably why I do this for a living, you know. Right, so the adage of being able to guess it in seven numbers is pretty interesting. Goofy little game. If you wanted to make a challenge on this one, what you could do, and I'm just throwing this out there as a possibility, you don't have to do this, but if you could figure out a way that you could take all of, well, I guess which part we'd probably have to put at least this part in a loop. If we put all of that code in a loop, we could also set up a prompt to ask the user to play again, right? And you can keep doing it just in case you were bored the first time, right? We'll work up to that point where we do run that with our programs. But folks, that's module 3, lab 2. Any issues or problems, anybody? All right, we've learned about while loops so far, and we just added a random number generator to the mix. Now we're going to add 3 new skills all at once as we write this next thing. The key skill that we're going to learn here is the for loop. We are already having a discussion about this before, but let's look at the documentation here from W3 Schools about for loops. So it says a for loop is used for iterating over a sequence that is either a list, a tuple, a dictionary, a set, or a string. So this is kind of interesting. So, I mean, that's not its only usage, but basically what this is telling you is for loops are built to run over structures. Now you'll notice here this thing that we haven't learned about yet called a list, and we are about to learn about it. So just, you know, hang on tight here. But a list is basically a data structure that allows you to store multiple values in one singular variable. Is really a good way to look at it. If you've learned other languages, you might think of this as a list, depending on the language, or you might think of it as an array, right? Either thing. But basically, it's one variable with multiple values, and then each one of the values, and we'll go into this again, so don't worry about like being tested on this, has an index value to indicate its position in the list. So for example, the word apple is in position 0. Lists always start counting at 0, by the way. Banana is in position 1. Cherry is in position 3. Okay, so this is kind of helpful. For loops, in many ways, are built to automatically traverse structures. And this is why they're so powerful in Python. And especially when it comes to language processing, why Python becomes the language of choice for language processing and why it's used for AI. Look at the syntax here first. So for anybody who's ever learned how to do a for loop in a different language, you're like, well, first you have to set up like a counter variable, like an I or something like that. And then you got to set up a condition, and then you got to set up an increment or a decrement, right? So if you know what I'm talking about, you probably have learned programming before. But in Python, if I have a preset structure like a list, I can just come up with any old loop control variable or, you know, counter or whatever you want to think of it. I think of this as, you know, sentinel value maybe, you know, but it will automatically traverse that structure. Right now I have 3 items in it, but I could have 1,000. This is why the syntax of Python is so marvelous, by the way. Regardless of its size, it will go through every item in the list in order and print it to the screen. So let's just run it really quick. All right. And just to prove that I could add, like, I don't know, what's another fruit here? How about an orange? Something like that. First one that comes to mind, right? It will automatically traverse that as well. This is 4 items. It could just as easily be 10,000. So just to kind of make that clear. All right. Now, an interesting thing that happens is, and we don't think about it like this, but when we are working with strings, what are strings, right? And so people who have learned other high-level languages, and the one that I point to most often in this regard is Java, because in Java, strings are not a data type, they're a class, right? That's truly what they are in every language. But what that means is that a string is really comprised of a bunch of individual characters, right? It's a collection of individual characters. And you can kind of think of a string as a list of characters. So in other words, that's position 0, 1, 2, 3, 4, 5, right? 6, it's a length of 6, right? And it's got index values from 0 to 5. So a string is really a complex thing. So we can traverse that just like we traverse a list. So I can traverse the letters in banana one at a time. I can process each letter separately. Okay, anybody that's learned another language like C#, probably most likely, or JavaScript, a lot harder to do that in those languages, right? Notice how simple it is to do in Python. It's like so simple, it's kind of crazy simple. It just, and okay, by the way, X could be any variable name. We usually use a single letter. You could use I, you could use X, J, T, who cares? It doesn't matter. So it is possible also, like we did in while loops, if you want, you can throw in break statements, right? In the same kind of criteria. So for example, in this situation, once we hit the word banana in the list, we break out. So you can pop people out of the loop. Otherwise, did you notice there's not really a risk of doing an infinite loop in a for loop? You can't make the mistake and get stuck. And this is the conversation we had earlier. So often, this is kind of the go-to loop for most professional programmers because that becomes an impossibility. The size of the thing that you're processing will determine it. Now, we can drop in, for example, the break statement here again, and we can also use the continue statement very much like we did in the while loop. So I'm not going to talk about those. The difference, remember, with the continue statement is it'll skip the banana, right? It won't print it because it'll continue, which means go back up to the top of the loop, but it will keep processing the rest of the list, right? Just like the while loop, same situation. All right, another thing that we can do with for loops, and this is introducing another command here, right? So another function is this thing called a range function. So a range function, kind of like what we just did in the number guessing game, where we were setting a top and the bottom, we were really setting a range of numbers. Now, if I just take the range function and throw in one value, right, it by default starts at 0. So if I run this, and I'm going to go into the triad editor here, what this is really saying is I'm running a range of numbers from 0 to 6. The 0 is implied, so I don't have to include it. I could, and I'm just going to show you this. I could include it and run it, and it'll still do the same thing. Okay, but with the range command, I can also change the starting number. So I can go from 1 to 6, for example. Or maybe you're not noticing the fact that it never reaches the top number. That's really weird. That's a very weird little thing. This is normal in Python, by the way. So if I want to run a loop that outputs 1 to 10, the closing number's got to be 11. It never reaches the top number. Once again, very different than other programming languages in how this would be accomplished. If you looked at a way to do this in Java, for example, you would say like I to 1, and then as long as I is less than or equal to 10, you would increment 1 each time, and then you would print it, right? And that's how you would set up the loop there. Here you just set up the range, it just does it. Weirdly, you can also add a third parameter and ask it to increment by a certain number of values each time. So I can run, if I want to do every other number, now it's just doing the odd numbers. Notice that? Starts with 1, counts up 2 each time. I can also go the other direction. So I can go from 11 down to 1. So I can go backwards. Oops. So I can set up the range to flip the other way. But notice it will start with 11. The question is, will it ever reach 1? And there's something I'm missing here, by the way. Right. It doesn't do anything if I do this. If I flip the order, I have to add the third parameter to tell it to count down by 1. Now watch it work. Okay. But notice it starts at 11, but it never reaches the 1. So if I wanted it to go to 1, that would have to be 0. And if I wanted to go to 0, then it has to be -1. This is like really bizarre syntax. And for people that have learned other languages first, this is kind of like mind-blowingly weird, right? However, when you get used to it, man, it is super, super cool. Some of the stuff you can do with the combination of these commands, right? So using that range command in the mix there. And you'll notice some of the examples, count by 3s. You can also, in a for loop, drop in an else. Once again, I don't see a lot of usage for that, but it is a thing. I'm not going to demonstrate it, but it operates just like the while one does. You can also, if you want, drop in a break statement. And notice how simple this is all in one line. You can totally do that. And to get even weirder, right, and we'll talk about this later, you can put loops inside of loops. Let's deal with the top level first, but I just want you to have you think about this. When I take, for example, 2 lists and they're the same size, right? It kind of really forms a table like rows and columns, you know, and a loop inside a loop can kind of help us traverse those structures. I will call that a little bit more advanced, so we'll come back to this when we need it. For right now, I'm just trying to think in my brain here, and I'm looking at the next exercise. Yeah, we don't need that for the next exercise, but there will be a point where we need it. Another thing that you might notice, and this is something I kind of ran into with doing functions, by the way, is if you're like building a loop and you don't have your code to put in there yet, but you still want it on the page so you don't forget what you're doing, you can just drop in what they call a pass statement. So it's not like flagging the debugger in the program. And that's just kind of a temporary placeholder, by the way, that programmers use to avoid getting an error. I don't use that very often. It's like if I'm not using a for loop, why would I even type it in? I would comment it out before I put that in. That's my brain, you know, but you can operate any way you wish. All right, let's go ahead and try to take a really quick look here at lists, right? So I kind of already learned about it a little bit, right? But just to reiterate, it's a single variable name with a collection of items. It could be strings. This is a list of strings, but it could also be integers, floating point numbers, or other much more complicated objects, by the way. So I kind of say that like really openly. Python doesn't care what goes into a list. Even weirder, in other languages, if I create a list or an array, it has to all be of the same data type. So like if I write a C# program, I could create a list or an array of integers, or a list or an array of strings, or a list or an array of floating point numbers, right? In Python, I can put anything I want in the list. I could put a number, and then a string, and then a floating point number, and then an object. Yeah, and when I say object, that kind of encompasses anything in Python. This is the really weird aspect of Python that makes traditional programmers very uncomfortable, frankly, right? Because you learn these strongly typed languages where you have to follow the data type, and then you get to Python, it's like, I'll put whatever I want in there. Oh, it works. Okay, great. Right? And you just move on. You don't even think about it because it just works. The only other language I can think of that's popular that kind of has this flexibility is JavaScript. But I don't think that JavaScript, I shouldn't say that in the video, right? Okay, let's leave that off the table for right now. The fascinating thing though, and I don't know if you guys are picking up on this, lists are defined with square brackets in Python. Right, so that's how we identify them. I would call this a hard-coded list. So in other words, I do the variable name, I put in an equal sign, I put in my square brackets, and whatever the list items are, I just put them in there all right away, and there's my list. It's all done and set to go. All right. What's kind of interesting about a list is a list is mutable. Okay, so what that means in programming, there's another fancy word for you. A mutable list means I can add stuff to it and subtract stuff from it. It means I can change it. Mutable means to be able to change. There's a counterpart structure called a tuple in Python that's defined the same way, but with parentheses, and those are immutable, meaning you cannot change the contents in any way. But for data processing really large quantities of data, it's a much more useful structure. Now, the list items are basically indexed, meaning there's an order to them. So in other words, the way that they're put in, apples first, bananas second, cherries third. That's not going to change. And they have index values starting with 0. So this is position 0, position 1, position 2. The length of the list is 3. The length is always 1 greater than the highest index number. Right. Things are ordered. If you add stuff to the list, it's placed at the end of the list, right? It's changeable, meaning we can add and remove items after the list has been created, and duplicates are okay. So I can have more than 1 apple on the list and more than 1 cherry on the list. That's kind of weird, but it's allowable, right? There's also a function called length that we can apply to a list, so we can test the length of the list and get back a numeric value. That can also be applied to a string, by the way, because that's basically a list of characters. And the data types can be any data type. Now, what they are showing here is lists of strings, lists of ints, lists of booleans. It could be lists of floating point numbers, lists of objects, mind blower, lists of lists, right? Or lists of a list of lists. You know, 3 dimensions is pretty weird, right? Don't like worry about that stuff right now, but they're trying to make a point. Generally, lists will be comprised of the same data type. People aren't usually mixed data types, so it is possible actually to mix them, right? Yeah, that is, I think that is just so weird, right? And the first time I encountered it, I was like, what the heck? This is allowed? This is the breaks every rule I was ever taught, right? Welcome to Python, folks. Do whatever you want, and it works anyhow. So what's really cool about that, though, if you think about this, it's more like how our brain works. Our brain, it's like, well, I remember the number, I remember the name, I remember the face. You know what I mean? And we group those together. Python's like, why not? Right. So that's the language is designed to do that. Right. Okay. So you can also run this function called type, which will tell you what it is. So if you don't know what my list is, you can ask what it is, and it will tell you what it is, and it'll tell you it's a list, right? You can also use a constructor. This is kind of weird. I don't usually do this, but you can do this. So we haven't learned about constructor functions yet, but you can run the constructor function and then throw in a list of things in parentheses, and then it creates a list with square brackets. I don't know why you would do that, but not just do this. Right? There are reasons. There's other types of data structures in Python. We will learn about each one of these, but a list is the one that we've been looking at. That's with square brackets. It's ordered and changeable. A tuple is basically the same. It's ordered. You use parentheses instead, but you cannot change it. We'll learn about sets and dictionaries later, but those are also very useful structures. Don't worry about memorizing what those are right now. All right, let's go back and start doing some coding here. All right, a lot of heavy concepts, right, all at once. Yeah, and what I suggest is, if you want to kind of reinforce those real sincerely, go back and read that documentation carefully, play with the editors, the try it yourself things, and see how they work, and fiddle with the numbers and see what happens. Right. Here's what we have to do for this program. It says create a function called loop letters. The function should have one parameter for a string, right? So we're sending in a string, loop through the string and print each letter, right? Next one is create a function called loop numbers, should have two parameters for start and end, loop through the range of numbers. So we're setting up kind of like the bottom and the top thing again. So kind of following that pattern. And then we'll do a function called loop list that should accept a list as a parameter. So you can take a list and move it around as a parameter. And then loop through the list and print each item. Call all three functions with appropriate arguments. And here are a sample run, right? So you type in hello, puts each letter on the screen, start and end numbers, put each one on the screen, and then we send a list and it outputs it, right? And you can see this is a mixed list, string, string, number, and Boolean, right? All right, so let's get busy here because we got some stuff to do. So we have some functions to create, and let's go over to Visual Studio Code here, create a new file, module 3, lab3.py. All right. As I did with the while loops, I'm just going to throw in some like lecture-y comments here at the top, just to kind of, drive home the concepts. So main thing we're really focusing on here is the for loop. The for is the keyword. You can use any variable name to help drive the loop. It doesn't have to be X or I. It can be like a word, right? Any way you want to put it. And what I like to think about, for example, is like if I'm iterating through a string that's got letters in it, I might call the variable letter, just as a thought, right? And then the loop will read in a more logical way, and you'll see what I mean. We always use the in keyword, so like X in letters or something like that. And then whatever data structure that we're working with, so it could be like a string, it could be a list, it could be a range, and then later on you'll learn it could be a tuple, a set, a dictionary, or whatever has multiple objects within it, we can iterate over it or loop through it. And then after the colon, we go into the body of the loop and do our statements. All right, let's just do one practice loop, just kind of so you see what I'm talking about. So for is one, all right, how about this? I was using this as an example. For letter in, all right, whatever, right? So that's one of my favorites. Because, or okay, or something like that. So for each, the way this reads is for every letter in whatever, we're going to do the following. So what are we going to do? Well, why don't we print each letter? All right, let's run it. Right, very, very simple, but there you go, right? So I took the word whatever, it was hard-coded in the loop, and it just put it back up on the screen. All right. I'm going to do a bunch of these samples, by the way, and as I'm doing these samples, I think what I'm going to do, I'm going to come back to the margin here, is I will just put in these little dividers so we have separation between all the different loops I do. That's, you don't have to do this, I'm just doing it for my own sake. So it's going to do the print whatever, dash lines, fresh line, and then the next loop. All right, so let's try the challenges. All right, so the first challenge was create a function. So we got to create some functions, I guess. Create a function called loop letters. All right, and the function should have one parameter for a string, loop through the string and print each letter. Oh, we kind of just did that, so that shouldn't be too hard. So let's define it. Defining loop letters. And we're sending in some sort of a string. Let's call it a phrase. Okay. Now, mind you, we're not in the loop yet. Now we got to create the loop. For, okay, I could do letters for X. How about that? In phrase. And name that, anything that makes sense to you. A lot of times programmers go for single letters here. Like they might just call it L or whatever, just because it's short. And then we'll do the same thing we did above, is we're just going to print X. What's X going to be? each individual letter of whatever we send in here. All right. Now we need to prompt for the letter, right? All right. Well, let's just really kind of, actually, I'm not going to prompt for it. I'm hard coding it. It didn't tell us to prompt. All right. So I'm going to call the function, and I'm going to say, hey, this really doesn't matter much, but it is kind of fun. Right? You know. So what is it going to do? It's going to take each one of those letters and put it on a separate line and go all the way through it up on the screen. Okay, so I'll tell you what, that's maybe too much to start with. Let's cut it and go, oh, wow. How about that? Very simple. Control S to save. Here's the runtime, folks. And I didn't want to do that. Okay, I'm sorry. All right, one more time. And of course, I hate that. All right, well, it did it, right? I just want to get rid of these extra little. How many of these can I possibly add? Okay. An infinite number, apparently. All right, this is embarrassing. All right, the other part of this lab, now that we're back from the break, is create a function called loop numbers. 2 parameters for start and end integers, loop through the range of numbers, and print each number. Once again, we're not going to prompt for these. We're just going to hard code this stuff, so it's going to be very similar to what we just did. All right, so back over to Visual Studio Code. I'm going to put in my goofy little divider here, just to kind of separate the content and the output. Close the console for right now. And this one's going to be called loop numbers. So loop underscore numbers. And then we're going to put in a start number as a parameter and an end number as a parameter. So this is the function definition here. And now we're going to run our loop. So we're going to say for each, here's an example, each number in the range of start and end, right? But you guys remember the little quirk with Python when it does numbers? You have to go one number past, so I'm going to end +1, right? Because otherwise that won't work, right? I'm going to put spaces in here. That just makes me more comfortable, but not necessary, actually. So if you want to hit the number, you got to go one past it. All right, what are we going to print? All right, so here's kind of a weird thing. So like in this for loop, we do the print statement, and the letters go this way. They go top to bottom, right? Kind of a pain. We're basically going to do the same thing here. So when I do my print statement, but I want, instead of going it up and down, why don't we go on the same line? And I'm going to show you a technique for doing that with the print statement. So I'm just printing the number, but I'm going to append to it this little Python formatting trick that's called end, right? And what this does, and I don't know if you guys are recognizing this or if you've ever seen it before, right? If you in your readings, but this is a little command we can add to a print statement so that every time we print, it stays on the same line and separates each output with a space. So instead of a separate line of output, it's all in one line. And then because I want a blank line at the end, I'm going to put in a blank print statement so I have a little separation. All right, next thing I'm going to do is I'm going to call this. So back over to the margin, I'm going to call loop numbers, and I'm going to hard code some values here. Let's just go 1 to 10. All right, here comes the runtime, folks. Let's get the code on the screen. All right, so it did our goofy long statement, it did our divider, and there's the numbers 1 to 10. So you notice how that works? So that's a handy little trick in Python. So if you want to put all the stuff on one line, that's how you do it. I don't have to have a space in between, but you have to admit it looks better that way if you're printing the numbers. So handy little trick. All right. I'm going to add another divider back in here. So I'm going to do the last exercise in here. This one's called loop list. Let's read the directions.
Just 1 second, just to clarify, is that end equals, that's that's different than the parameter end. Is that correct?
Correct, right.
Okay.
Yeah. We could call this start and finish if that makes you more comfortable.
No. I just wanted to make sure I was seeing that right.
Yeah, and you notice like when I highlighted the one in the parameter list, it is sort of highlighting this one, and it's not really, it has nothing to do with this. So just to kind of prove that, let's do it like this, just to alleviate that concern and see how it still works. All right, I'm moving on to the last little thing. Create a function called loop list. This should accept a list, loop through the list and print each item. And what we'll do is we'll come up with two different lists. So one with text and one, or maybe three, maybe numbers, whatever. We can throw whatever we want at it. So we'll play with that. All right, here comes code. Let's define the function first. So we're going to call this loop list. And what are we throwing in there? Some sort of a list. I don't know what it's going to be yet. But we'll send those in separately. The for loop. So we're going to, for each item in list, right? So isn't that beautiful syntax? We will just simply print the item, one on each line. That's the function. Back over to the margins to call it, but you know what? Here's what I said last time, right? So this is just some comments here. Create a basic list with the variable name and square brackets with each item separated by a comma. So the one thing I did is I had a list of strings. So I list of guitar brands, basically. How about numbers? This one I'm going to type in because I don't have this one pre-created. And then I have another one here that's a mix of data types. I'm just calling it my list. So I got strings, floating point numbers, integers, Booleans, and weirder, a list also. This is kind of weird, right? So I just want you guys to kind of think about this. So that list contains this list. I'll tell you what, I won't do that one at first. Let's comment that one out for now. And then let's call the list to run. And all you have to do is loop list. And then inside the parentheses, which one am I looping? Well, how about guitars? Let's start with guitars. We'll run it. And there's the guitar brands right there. I'll pull that back up so you guys can see it. If I want to run the numbers list, I'll just call that loop list numbers. Running it again. So the guitars and the numbers. All right, now let's activate this weird one. Does anybody have any predictions as how it's going to output the guitars? Yeah, you will see, basically. Right. So it should be sleep on one line, not Python on one line, 5 on one line, true on one line, 3.0 on one line, and we'll see what happens with that one. This is kind of interesting. Watch the runtime. Right? Sleep, not Python, 5, true, 3.0. And it just put the list on the screen with square brackets and single quotes. Isn't that weird? But what this shows you, and I think this is the bizarre thing, it's just kind of reinforcing the fact that a list can contain a mix of data types, including other complicated objects like other lists. That is really weird, but totally doable. Okay. Everybody got that to work okay? We're okay-ish. All right, we're going to move on to the next exercise, folks. Next lab, I should say. So I'm going to fast forward here. All right. So this one's going to be a genre tracker, and you'll notice that the the topics of discussion, while loops, we already did that. For loops, we already did. We already talked about lists. But we're going to learn how to add stuff to lists because that's going to be one of the requirements here. So we do have a method that we can add to a list called append. And this is kind of the basic syntax. So we can start with our list of fruits again. The append function or method really will just basically add orange to the list. So if I run it and I do an append command, it adds orange. Where does it add it? To the end. Right? Really, really simple, right? Now, if you kind of follow through this, if I, this is weird, but I could take a list A, put it in a variable, right? And then I can append list B to list A. That's a doable thing too. Check this out. Not exactly how you might expect, but it still does it. And really what it's doing is it's adding the B list as a singular item in the A list. Right. Okay. I don't see a lot of practical usage for that, but I'm just kind of showing it to you so you know that it's a possibility. The only one we really need for this exercise is append. By the way, I don't think we need the remove, and that's not listed here anyhow. All right, so here's the requirements for this. Use a while loop to add genres to a list until I assume it should say until entering end, right? So it says, please enter genres of music you like. Type end to move on, right? So notice that we're putting a menu on the screen too, right? So list out each genre, assigning each one an incrementing number, starting at 1, not at 0, but at 1, because humans count with 1. Choose a genre and include a special message when listing it. All right, so you might enter like country, ska, R&B, then you type end. And then when you choose the second menu option to list the genres, it'll show you what it types. But there's another thing here. Update the application. We'll do this as a separate step. To use a menu and functions for the following: get genres, list genres, and then exit. Right. So we're going to kind of do that kind of over and over again. I am noticing here, right, there's this kind of like, like weird little message. They don't really explain how we get to that, but you know what, we're just going to type in genres and we're going to take it one at a time here. So let's play with that for just a moment. All right, let's start in Visual Studio Code by creating a new file. So I'm going to create that. This is module 3 lab4.py. Okay. Now, here's kind of the unwritten piece of this, because they're not really telling you to do this, but I'm going to tell you to do this. Why did we get a command or information on how to add stuff to a list? Okay, well, here's the reason. All the genres that we type in, we're going to put into a list structure. So the list is going to hold all the genres, right? So in order to build a blank list, there is a way to do that. And this is really weird, but you just give it a variable name and an empty set of square brackets. And now we have a blank list. Has nothing in it. So if I output that to the screen, I won't see a darn thing, right? All right. One thing that you notice in the sample run, let's go look at the sample run. And you will at some point get prompted to enter the names of genres, right? And then you get this, kind of generic thing that allows you to operate the program. All right, so one thing that I guess we have to put on the screen is please enter the genres of music you like, type N to move on. But okay, so get genres, list genres, etc. So let's just get this first part going first. And the way that I'm kind of seeing this, right? Okay, and there's a lot of interpretation here because it's not very specific as to how we're going to do it. But the way that I'm going to build this with intent, by the way, will help you build the homework assignment. So that's why I'm going to kind of do it the way that I'm doing it, just so you guys wonder, because it's not really exactly following these directions. In fact, if you guys don't mind, let's take a really quick look at the homework assignment on this one, so you see what I mean, because we're going to do a vacation planner, right? And I want you to notice that it's kind of the same. There's going to be a menu. You choose an option. You're going to add stuff, right? And then kind of build basically a list, right? Is what you're going to be doing in the assignment. All right. So just kind of going back then to this. All right. Let's start coding here. All right. We're going to break this down into a couple different pieces. We have plenty of time left, so we're not like in a time crunch. But think about like what we're going to do here. So we have our blank list already ready to go. The one thing that we're going to do is we need to put a menu on the screen with all the options. The other thing is we will add genres, right? That's kind of a repetitive process if you feel that. Then we're going to list the genres. That's kind of a repetitive process, right? And then we also want to have the ability for the user to kind of choose the menu options and deal with the menu options, right? So this is all kind of, I'm going to break this down into pieces. And real frankly, folks, this is probably the first program that we're writing that's kind of like a real program in terms of functionality in my mind, right? So follow with me here. What I'm going to build first, aside from the blank list, is I'm going to build a menu function, and then we'll have a starting point, because this we can put a menu on the screen, right? And I think this is kind of a good place to start. So I'm going to build a menu function that basically puts it on the screen and takes whatever choice the user made and sends it back to the regular program. So I'm going to call this get menu option. We don't need to send anything into it. We're grabbing something from it. Right. So I'm just going to do a series of statements here, just for example. The first line is going to say music application menu, right? And then I will put in 3 print statements with the options for the user, which are 1, to add a genre, 2, to list the genres, and 3, to end. Notice blank line here, tab, tab, tab. So this is going to pop up on screen when we call it, and it's going to grab the input from the user. So we need to have an input statement here, and the input statement is going to grab the user's choice and send it somewhere else. I'm not going to store it. I'm just going to return it. So the input's going to be a number. I'm going to convert it to an integer, and I'm going to grab the input inside the statement. All right. And the prompt is going to be, I'm going to do it with, well, I did it with an F string last time, and I'm not really sure why I did that. It's not really necessary, but I did it. So I'm just going to reiterate it. And I'm just going to say selection, colon, space. So all this function does is put the menu on the screen and grab the choice from the user and sends it back. Okay. All right. Now you have to start conceptualizing something else. Here's the next conception. When we run this program, this is kind of one of these programs that the user is going to control the runtime on this. How long this program runs is up to the user. What's a really useful structure for doing that? The while loop is a really useful structure. So I'm going to build that next. And I'm just going to say while true, so forced to run, right? The program is going to be forced to run. I'm going to create a variable called choice, And in there, I'm going to run get menu option. And what's that going to do? Puts the menu on the screen and gets the choice from the user. Now, okay, if your brain is saying, well, you could have just done all that right inside the while loop. Yeah, I could have, but this is one line. That's 5 lines. Right? A little more efficient. All right. Then we got to deal with the choices that they make. So what are the choices? Well, if the choice is equal to 1, what does it say there? Add genres. Why don't we create a function called add genres? This is going to underline because I haven't created it yet, but I'm not freaking out to that. And actually, let's call it plural because that's really what it is. Okay. Then we'll do an else if, if the choice is equivalent to 2, what are we doing? We're listing them. So we'll create another function, hasn't been created yet, called list genres, parentheses. All right. And then finally, there's a third option, right? Okay, so we ran into this issue before. I'll show you what I wrote last time. Okay, so I'm just going to move this over for a second because I do use cheat sheets, right? Like I have the code already complete. That's how I copy paste it. Last time I just went right to the else, right? So they either choose 1 or 2. And if they choose anything else, it exits. That doesn't really make sense, right? That should be an error message. I should have a choice for 3, which is break, and an else, which is an error message. So that's what I'm going to do this time. I'm just kind of showing you that I'm like re-engineering my stuff as I'm going along here. So let's do an elif choice is equivalent to 3. What are we going to do here? We'll break, right? If they choose 3, they want to be out of here, right? But hold on a second. Okay. They're going to get the genres, list the genres, or exit. Okay, that makes sense. Okay. I just got to confirm it. And then the else is going to be, they type something else, a different number, and then we'll just have a print statement. Please choose option 1, 2, or 3. Okay. Now, notice that this is not defined yet. Okay, so here's how you can deal with that, because those are underlining, and that's not a good thing, right? So I could, for example, define add genres, right? Parens. And then what was that magic keyword? Pass, right? It gets rid of the underline. Remember? And then we are working in the Microsoft product, and Microsoft in their IDEs, when you hover over a problem like this, it's telling you what the problem is. List genres is not defined, right? And it says view the problem. Okay, well, we already did. And then did you notice it has a quick fix? And I'm gonna, okay, search for additional import and add a type to suppress the warning. Okay. All right. So that's the way you can kind of ignore the warning. I will tell you another, like if you're working in another higher level tool, like if I was working in PyCharm, for example, or if I was working in Visual Studio, one of the quick fixes would be create the function automatically. That's not listed here, right? But I just want to point that out. All right, so I'm going to do the same thing with that one. So I'm going to come back to the margin. I'm going to define list genres, colon, and pass, and then I'll replace the pass with the actual code. So let's think about the process now that's going to happen, right? Okay. This is a function. It only runs when called, same, right? The while loop will execute. It's forced to run. It'll put the menu on the screen. We grab the choice, and depending on the choice, we'll execute the code. The first one is to add a genre. So what does that look like? All right, let's kind of break this down. First, we want to prompt the user to enter one, and I'm going to do it like this. I'm going to create a variable, and I'm going to call that variable, last time I called it user genre, right? I'm just going to do an input statement. This is going to be text, right? All right, so what's the text going to say? Well, I guess I'm going to start with a new line. I'm going to move it down. I'm also going to tab it in. So new line and a tab. And then we're just going to say enter a genre. And then and stop, right? So that we're looking for the keyword of end. And I got all my stuff in the way here. I'm going to put in a colon and a space. So that's the prompt. All right. Now, your brain's probably telling you, okay, I could write an if statement here to handle this, right? Because if they type end to stop, but we really want to do a while loop. And how long should the while loop run here? Until they type end in all caps, right? So here's the while loop. While user genre does not equal end, we'll do the following task. We're going to take the genres, that's the list up here, right? And we're going to run the append command, the method technically. And what are we going to append? Whatever they just typed in. You know, they type, you know, country and Western. Right. That's the first part. So we're adding the genre to the list. Then we want to prompt them again, right? Because if they want to enter another genre, but the prompt is up here, right? So I'm going to grab that prompt and reiterate it inside the loop, right? I am going to remove the new line though. I'm just going to do a tab. So I prompt, I grab, you know, R&B, adds it to the list, prompts again, enter another genre or type end to stop. Rock and roll, you know, heavy metal, punk rock, whatever. You just add your stuff and you keep going, right? All right. Now, this is really kind of goofy stuff, but at this point, I mean, we sort of have enough to kind of run the program. I mean, list genres should do what? It should just put that back up on the screen. So let's just do a really simple list genres, and then we'll ramp it up a little bit. So instead of doing pass here, how would I print all the genres? That's kind of a weird thought here, right? All right. What if, could I just print the list called genres? Sure. And you know, for right now, I mean, this really truly satisfies kind of the requirements of the assignment if you kind of look at it, right? Right. So the list, and they have like a bunch of like extra verbiage in here. I'm not really concerned about that. If you guys follow what I'm doing, I'm cool with it, but you could also follow that. All right, so let's see what happens in the runtime of this. All right, you guys ready? All right, here goes. Control S to save. Here comes the run. I'm going to make the console nice and big here. All right. So there's no genre. So if I right now type 2, it gives me a blank list. You notice that? Right. And it doesn't look very nice, but it is outputting it. All right. So let's go ahead and type a 4. Okay, so we proved that the error messaging works, right? All right, let's try 1. Okay, enter a genre, end to stop. All right, let's start with the most important one. Yeah, it's a joke. And then we'll do country and Western. And I don't know, you know, pick a category. And then I'm done. So I'm typing end in all caps. And now we'll list it. Oh, but okay, now I got to come up with another one. All right, R and B. And then end. So I pressed the wrong number there. But now we want to list number 2, and there's all the genres. Okay, primitive output, but proof that it's adding it in there and adding it in order. So it's working. So we're capturing the information and storing it. All right. Now, I'll be real frank here. There's like a thing that's, I think, missing from this assignment description. I wonder if this is kind of like a weird little hangover effect of the copy paste from last year. But in our exercise from last year, when we did this, you'll notice that there's this little message that pops up. So when we do list, we really should display that message, which should count the number of genres and put it on the screen, right? And then number each one of them. And for certain styles, that adds a message to. I'm not worried about the message right now, but we can add that in. Let's just worry about this message and the numbering and get the list to go like this instead of going across. Yeah, okay, so I got a message in the chat here. I just realized while testing that spaces are also saved, does this mess with your code when dealing with the operations and Boolean values? It sure can. Yeah, it sure can. Right. This is why we use the strip command, by the way, because it helps to eliminate that issue. But when we're typing in text, which is the name of a genre, you know, I mean, that's pretty much kind of a basic little thing. All right, let's go ahead and output the list in a better looking fashion here. So I'm going to close the console for now. And now we're going to ramp up this function. So the first thing I want to do is first decide, and this is kind of a weird decision, is remember the length function? If the length of genres is greater than 0, then I want to do all that fancy output. But if it's empty, it makes no sense to put anything on the screen. All right. So I'm going to put in I don't know, I'm just going to put in a comment, you know, whatever here. And then I'm going to type my else. And the else is going to be basically this. You need to add genres first. And you know what? Let's help them out and send them to the add genres function. See where I'm going with that? So if they come in, the first thing they do is they go into the app and they say list the genres, and there's nothing in there. I'm going to say you need to add genres first, and it takes them right to the function that does it. Right? So if they, you know, are trying to break the program or whatever, that we're forcing them to enter them in. All right. Now let's think about if we're going to put a list of the genres on the screen, how that would function, right? So here's a couple of thoughts, right? They want us to number each one. Let's set up a variable for numbering them. So I'm just going to use I because that's pretty common. I'm going to start it at 1. That way I don't have to worry about it. Then the process of listing the genres is kind of mechanical. So I could use a loop for it. So I could say for, I'm going to call it style in genres. How would I display the genre? All right, let's think about it. I want to display the first thing in the list. Remember I used like index numbers for those? All right. In fact, I'm going to do something kind of goofy here. Just this is a sideline, but I think you guys will find it helpful. I know I kind of already explained it, and you guys are like, why is he pulling out Excel? What the heck is he doing? And there's method to my madness, so just flow with me here, if you will. I'm using Excel because Excel is really good at like kind of highlighting this. So I'm creating this like little structure here, if you guys can see it. But you can think of kind of like a string or a list as this like thing that has a singular name. So I might call this, genres. Hello. Okay. Genres. Right. And each position in my list has an index value. Right. And so I can use Excel to help me kind of illustrate these concepts. I'm going to center all this content, by the way. And maybe my making these small was kind of silly. All right, too big. Maybe not quite so big. There we go. All right. So for example, it might be like metal. These are strings. Imagine there's double quotes around them, etc. Country, Western, whatever, etc. All right. So my thinking here is, all right, when I refer to something inside the list specifically, right? We haven't talked about this yet. Like, how do I get the list to display this one? Okay, here's the syntax for it. So I would say, well, I named it with a capital G, which was a mistake. But if it was named with a capital G, I then use square brackets to indicate the position. So for example, I can also use this to assign values. So if I wanted to assign, rock to position 0, I would do it like this in Python. Right. If I want to print what's in position 2, I would do this. Position 2 would output country. So that's how I kind of access the contents of that list, right? We use the index numbers to do that, right? So this is kind of helpful as we write the next part of the program. So like when I start doing it, you guys aren't like, what the heck is he doing? Right. And so, all right, let's think about like a really primitive approach to doing this, because really what we need to do here is a print statement, right? I'm going to use F string. So there's my little F, so I can use the variables directly. What am I going to output first? I'm going to output the index number, which is 1. So whatever I is right now, and then a period following it, period, and then a space. And then I'm going to list the style in genres. Now, be mindful of the fact that I'm calling it style, but that's each individual item in genres. So here I would list the style. Okay, so this should output all of them and list them numerically. One other thing that needs to happen in that for loop is every time that for loop runs, it should also increment I by 1, right? So that, the next thing in the list gets an increased number in front of it. All right, let me run this. I know this is kind of a lot to absorb all at once, so I'll run it. We'll go back and we'll take a look at it. All right, so here comes the runtime, folks. Control S to save. Here comes the console. And don't worry, I'll put the code back up on the screen. All right, let's go ahead and try to break the program. We're going to tell it to list first. So what is it going to do? It's going to recognize, it's going to be an error message, and then it sends me into the add a genre. All right. All right, I typed in a few genres. Supposedly they're in there. Now I'm going to hit 2 to list them. And there we go. So we have each one is numbered. Each one is listed, even with my typos. And yes, if I type in extraneous spaces, those will be captured too. Right? We're not worried about fixing the entries right now. We're just trying to get them in there. Right? Could it look a little better? Yeah, sure could look a little better. I mean, I could argue that I could tab it in. I think there was also a message that went with it. Oh yeah, we got to put that one in too. So you like 3 genres, here they are, right? All right, let's copy that. And let's go back to the program. Close the console. Let's add that in to the list. So that could happen here. So I could do a print Let's do the F string approach. I'm going to paste in that verbiage, but this number needs to be dynamically generated. And the way that we're going to do that is inside of curly brackets, we're going to take the length of genres. That'll come back as a number, and it should tell us how many genres we have in there. Right. I think also a good idea, and from what I noticed from the output, is a new line is appropriate here. And arguably, maybe you could tab these in. I think that was part of it too. All right, let's save this and run it. See if that helps. All right. I'm going to go right to add. I don't know. How about this one? All right, I'm struggling to think of some right now. Okay, so we type those all in. Now let's see the output. Here's the 2. You like 5 genres? Is that correct? Yep. Here they are. Very cool. All right, so it seems to be working. And if I want to add more genres, let's try that. Let's add some more genres. Oh gosh. All right. Oh yeah. Metal.
Reggae.
The Italian Renaissance.
Italian Renaissance. All right, you got it. Hopefully I spelled that correct. Renaissance.
2 S's.
2 S's. Oh well, too late now. All right, we haven't learned how to write the script that allows us to edit each entry, but that's possible too. We also can write code that deletes an entry, removes an entry, all that kind of stuff. Oh, that can all be done, but that's coming. But we're starting to just get the stuff in there right now. How about Hungarian folk music? All right, that's kind of like saying like Swedish death metal or something like that, right? And let's just get out of here now. Okay, let's list them. There we go, it captures it. But it's pretty slick, right? I mean, like we're getting to the point now where we're getting a program to run, to keep running, give it information, store the information, retrieve the information. This is powerful stuff, you guys. This is pretty cool. All right. We do have 8 minutes left. And there was a wrinkle that we added in last year. Like, so if some people, for example, and I'm going to show you the code I'm going to copy from here before I type it in, is what if some people enter certain styles of music, you can add a little message to it, right? So like if you add metal, you can say you rock, or if they type country, that's so nice, or jazz is groovy, you know, etc. So you could write an if statement to handle that. I think I'm probably going to refrain from adding it to the program, but if you were wondering how they got this message in here, ska, that's a lot of upbeats, right? Because that's always on the upbeat and ska. How about we just write a simple if statement that if somebody types in ska, that we respond with that message. I think that would be enough, right? That's not really a requirement of the assignment. I just think it's kind of humorous. So what we could do inside the loop, right? We would print this, but if style is equivalent, and we do ska with a capital S, then we can basically borrow this print statement, same print statement, but we're going to add a message. And it's just going to happen for that genre, right? If you wanted to add a message for country or whatever style, you could write some else ifs in here. right? But otherwise, only if they type ska will they get that message. Else, they will get the regular print statement. But if you want to add other messages, just feel free. It's just kind of a fun little wrinkle to add into the mix. So let's run this one. So I'll try to list first to, yep. Nope, we got to add stuff first, sorry. All right, so let's go ahead and add metal, death metal. I'm being really funny here because who would have ever thought there'd be various flavors of metal, right? Or maybe there's rock, hard rock. Here we go, ska, country, and western. And we'll end. All right. So now we're going to do a list. And there we go. But notice how ska's got the message because it hit the if statement. All right. I think we're at a logical stopping point here, so I'm going to terminate this video.